Hello, uh, I'm Ivan Taylor, and I'm the senior researcher at Policy Dynamics Incorporated in Ontario, Canada. And I'm also a member of the International Council on Systems Engineering. In fact, I'm the membership director of INCOSE Canada. And this is a presentation that I'll be giving to INCOSE Canada at 8 p.m. on Monday, December 2nd, 2024. So this recording today is a rehearsal I gave of the presentation to the Resilient Systems Working Group of INCOSE. And in the presentation, it's a very short presentation, and I made some assumptions. The presentation is called "Why Systems Engineering is a Smart Investment," and it's intended for any systems engineer who is trying to explain to his leader, his boss, his supervisor, his manager, who maybe doesn't know much about systems engineering and really doesn't care about systems engineering. What they care about is cost and profit, the bottom line. So this is a short presentation where I try to explain, as I said, why systems engineering is a smart investment. And and like I said, I'm going to be presenting this on December 2nd. And so, if you like this presentation and want to see me present it live and ask questions live, you can go to the Canadian chapter, INCOSE Canada chapter website and register for the presentation on December 2nd. I'd love to see you there. Um, However, as I said, this presentation is intended for all systems engineers, and so if you're interested in getting the slides that I developed for this presentation, just put a note in LinkedIn, and I'll send you a copy of the slides, and you can do whatever you want with the slides if they can help you explain, as I said, why systems engineering is a smart investment to your boss. So, let's just. I just want to say I made a few assumptions. As I said, I assumed that this leadership, is really not interested in systems engineering. Doesn't know anything about systems engineering, and all they really care about is the cost and profit and the bottom line. Also, I assume that they have very little time. These people are very busy, and I tried to respect their time. So I have a very short presentation. And um, let's listen to the presentation together. Like I said, if you have any comments or if you can make the presentation better for December 2nd, just put a comment in the chat in LinkedIn. Okay.
And Ivan, if I may, you're a little bit soft. If you can adjust your mic, that might help a bit.
Okay. I do actually have a problem with my voice that I do speak quite softly naturally. But anyways, yeah, this is a presentation that I prepared for the Canadian INCOSE chapter, and I'm giving it on I think December 2nd. And so any feedback I can get on this presentation to make it better would be great. One thing, of course, is my presentation to the Canadian chapter will probably be much longer. I don't think we have enough time today to really do an hour-long session on this, but I'm hoping to try to get a good discussion in the Canadian chapter. Anyways, so the title of the presentation is Why Systems Engineering is a Smart Investment, Managing Complexity, Reducing Risk, Saving Money. And the intent of this is basically similar to the elevator speech, is to have a presentation that would appeal to an executive, a leader in an organization who may be very short on time and really, is really focused on the bottom line, which is basically profit and cost. So another aspect of this presentation, which I want to mention, is I want to thank Tony LaCasa for suggesting this, because when I gave an earlier presentation on the SE value proposition, he said, well, do you have any data on this? And so that was a challenge for me to find actually quantitative data. So I tried to do that, and you can comment on whether I was successful. Okay, so what is systems engineering? Systems engineering is about making sure the whole system works together, and it's an interdisciplinary approach for understanding customer needs early, designing, testing, and validating systems, and managing complexity and integration of subsystems. So this is my own ideas, but I have another slide, which hopefully it'll come up later, is maybe a more clear description of the actual steps involved in systems engineering. Anyways, here's some quantitative information about the benefits of early systems engineering investment. More SC upfront means fewer surprises later, and spending 12 to 14% of the budget on systems engineering at the start can save 50% or more of overall project costs. And I have a reference there at the bottom.
Ivan, it's
Yes.
Bill.
Mhm.
Go back to the previous slide, please. I have found in teaching that when you talk to people about processes that we have, that it helps them get a better handle. So I might suggest that if it fits in here someplace, that you might mention that we actually have disciplines and processes rather than people. I'm afraid people walk away with this concept that we've got a boiling thing here with smoke, and we know how to work the mirrors.
Yeah,
But in
have
reality, we need some some reference that there is some actual foundation to what we do. Over.
well, I have another slide later, and maybe I should put it up in the front about
Okay.
how we actually do systems engineering. But I also want to make sure that this presentation contains no jargon. So
Understood. Understood.
it's for someone who really doesn't know systems engineering and really doesn't care about systems engineering. What they care about is, like I said, they care about the bottom line.
Yep.
And the bottom line is that, like this document that I found said that a 12 to 14% of the budget on SC can save up to 50% or more on project costs. So the next thing is that the value of early systems engineering is it avoids costly mistakes, and fixing problems later in the project can cost up to 250 times more than fixing them early. And I have another reference there. And then return on investment. I think you all know about this, that for every dollar spent on systems engineering, you can save between $4 to $10 by avoiding mistakes, rework, and project failure. Okay, here's the slide I was mentioning, Bill, that basically explains, I think, in simple words, how systems engineering works. One, we understand the problem and what success looks like. Two, we explore all solutions and make sure they fit together. Three, we prepare the system for testing and support early. Four, we manage and track requirements so nothing is missed. Five, we ensure all parts of the system fit and work smoothly together. And six, we monitor progress, adapt to changes, and stay on track. Does this help you at all, Bill, or do you want something else?
I think that's straightforward. That's when you said when you stated the audience intent, it made it a little clearer. So I think this is great. Thank you.
Yeah, you're welcome. Okay, why systems engineering? Is projects without systems engineering often fail because of missed requirements or late discoveries of requirements. And SE ensures that the requirements are clear. So we build the right system and build the system right. That's a little catchy. And systems engineering helps keep projects on track. It provides better control over costs, schedules, and quality. And without SE, you might not know something is wrong until the project is over budget or delayed. Why systems engineering matters across industries: aerospace, defense, infrastructure, transportation, energy, healthcare, all benefit from systems engineering. And systems engineering isn't just for engineers, it's also a manager's tool that keeps any size project on track. So SE is essential for complex, high-risk projects. So in summary, SE makes business sense. SE helps us deliver projects on time and within budget. It ensures that we get the system right the first time, avoiding missed requirements, integration problems, costly early mistakes, and delays caused by rework. So investing in SE protects against risks and boosts the bottom line. There you go. How am I gonna pad that out to an hour?
Got a lot of talking to do. Ivan, one other thing that you might want to throw in there that comes up in some of my discussions with others, the unanointed, if you will, is they don't seem to understand where systems engineering fits into an organization. They've heard all about how PMs are supposed to work and the finance people, whatever. If you have some thoughts and comments on where SE fits into an organization, that might, since you're talking to some people just getting started, it might help their understanding, because everybody seems to think that, oh, well, just get the project team, get them together, and they'll take care of it. And that's, then we have to step in and say, yeah, well, there's this systems engineering thing that's also involved and heavily involved in influencing. If you think that fits to your audience, over.
That's super. That's super, Bill. Yeah, I think, are you talking basically about an org chart?
Something like that. Maybe if yeah, no, not a process chart might be more like it. You're starting with the requirements of where the systems engineers fit in and how they can, let's say, we control the requirements, making sure that they get done. So the project management, and we do oversight on the project management team, right? So yeah, something like that. Although mentally, I don't know, John may have, I think John did something like this a long time ago, or somebody else did something like how we had the hooks that systems engineering has into a development, or into the SDLC, for example. That maybe that's it. Just trying to show people that this is how systems engineering works within doing a project. They're not just in there at the very beginning. Yeah.
So maybe we have a timeline.
I think that's an important way.
With inserting systems engineering in places in the timeline.
Yes, I think the timeline is an important issue, because something I've seen, which I think is a problem here in the UK, is a tendency for very large projects, first of all, to let out the contracts to the different subsystem suppliers. And a peer of those contracts is the systems engineers, who then really only become clerks to manage the paperwork, but they're not actually involved in the development of the concept. And so I think showing that the systems engineering has to be involved in the development of the concept in that timeline and sequence of activities is a critically important part.
Yeah, I definitely emphasize so far in the presentation, getting systems engineering in early. Do you think I need to also emphasize systems engineering in later parts of the project?
May I suggest that you think of it more in terms of trying to, in a simple way, convey the concept of life cycle. Convey the fact that systems engineers have identified the fact that successful projects go through certain steps, and systems engineering takes advantage of that knowledge.
Sounds great. Sounds great. I think I can use something.
Yeah,
there.
yes. To John's point, Ivan, you may go ahead and introduce the SDLC or something like that, or some life cycle,
Yeah.
extremely high level model, just to kind of say, well, this is what you're going to go through. And they're probably never thought about it. And most people, when you say you start with the requirements and okay. And the SE's role is to help manage this process, or some words to that effect,
Yeah.
but show the involvement. And I think that they might really enjoy that idea that, oh, there is some structure to this craziness.
You might even show that graphically by showing it going down the right side of the slide where you had the enumerated activities. Combining a graphic with the enumerated activities might be a way of getting it across to the layman.
Yeah, I don't understand what you're saying, John.
Go back to maybe slide 4, the one where you said it might satisfy Bill's question.
No, farther down.
A little
farther
further.
down.
A little
Keep
further.
going. Yeah, there you
Okay.
go.
Yeah, I mean, you could, along the left vertical column or the right vertical column, show a timeline of the progress through the phases of a project. And
That
those track to the 6 items that you've established here.
Now,
Or you could just put 5 steps of SDLC on the right hand side. That might help also.
Yeah.
Something to tie the two thought processes together. This is how most people would think on the left, but this is how we think of it on the right.
Yeah, I'm sure there's a good sample life cycle
there
you
is.
could pull right out of the handbook.
Yep, right out of the handbook.
Yeah.
And there's a couple out there with that big, the big circle that starts here and follow the loop and the yellow brick road. But I'm just suggesting, I think there's something there that would help them understand how you look at the world differently than they do, because this is how most of them look at it. They say, well, we're just going to do these things and be done with it. Well, no, it's not quite that simple. It's more, it's not so much complex, but it's more stringent.
And Ivan, pardon me, on this one, number 2, I have a little bit of a nit. We explore all solutions, then we select the best, and we make sure the selected ones fit together. But I think you do want to mention that you select the best of a range of solutions in number 2.
okay.
Or as they say in a movie, you choose wisely.
Yes.
Could we remove, make sure they fit together, because we do say that in the number 5.
You could. You're right. Yeah, I think the fact that we explore a broad range of solutions and then select the best is something most people can understand.
Sounds great.
I think there is actually value in what Ivan's done there with the explore solutions at 2 and then at 5, because the one at 2 is about planning the work that's going to be done so that it will fit. And then the one at 5 is the verification that it does.
Mm-hmm.
And I think putting that point across shows that doing the systems engineering work is critical to actually designing a system which, when assembled, will integrate relatively easily.
Yeah, so
right, because to me, the talking point on that one, Ivan, is that all too often these projects get started and some CEO says, well, I want you to use this solution.
Right.
And you're going, wait a minute, let's make sure, we've all had that problem, I think. So I think this is a key point to everything that we're going to try and figure out what actually does work, not what the CEO wants.
What if I just change the word fit there and say best solutions? So change they to best solutions. So make sure the best solutions fit together.
That's true. Yeah.
Sure.
Does that help, John? Would that be good?
Yeah, that's a good way of wording it.
Yeah, I don't want to go on to another line. I want to keep all those points in one
Although doing that does seem to express the idea that you select the best of each thing separately. But what actually matters is you have the best system level solution, which means you may have less than the best in one or more of the components because they work together better and give a better overall system level solution.
Yeah.
Right, right. That's interesting. Yeah. Yeah, because we are systems engineers.
Yeah.
Yeah. So how do you say that in 4 words?
Maybe I just say
Optimize
it.
the system,
Maybe
not
I
the
just
part.
say it. Maybe I just
Yeah.
say it and I don't put it in the slide.
Yeah, even with only 5 slides, you're going to have to do a fair amount of talking. Your talk track will be pretty big. So I think all these things are in there. I mean, I think it's a great bullet. We just got to have to, and explain it. And when they say, I'm certain somebody's going to pop up in the back room and go, "What do you mean by all solutions?" Okay, so be ready.
Yeah, that is a little bit of hyperbola. Basically, I think John's got it right. We have a broad range of solutions, and rather than all solutions, obviously.
I have a comment.
Go
I
ahead,
think
Scott.
I think when you use the word best, it's good to identify or define what you mean by best. Are you talking about performance?
I think we're talking about cost effectiveness, maybe. Would that be a better term?
How about effective instead of best? Would that be easy?
Well, I think
Blended.
there's a cost element to it. You wouldn't have the most effective solution because it might be too costly.
True.
I'm a
True.
big believer. I'm a big believer in understanding diminishing returns, and perfection is infinitely costly.
Well, and that's an excellent point, Ivan. I hope you do bring that up because most of the people who run across don't seem to understand that the cost component of all this work, and it's a very good point.
I'm thinking of some more graphics, and I have an interesting idea about risk analysis, and basically it's all about an S curve, which suggests that the investment in avoiding risk, you have to make at least some investment just to make any progress at all in reducing risk. And then eventually you get an S curve where you start investing more and more to avoid risk. But then eventually you get to a limit and you say, we're reaching diminishing returns now, and we have to basically say, how much extra do we want to spend to reduce that little bit of risk at the end of the tail? I think it's a very much a subjective judgment about what kind of risks you're talking about and how important they are. But I think just the idea that there is this S curve with diminishing returns, that I think that's a powerful idea.
Yeah, Ivan, just be careful if the room has a bunch of cyber people in it, they may go nuts. To them, there's no expense too great
Yeah.
for
Yeah. Well,
absolute security.
This is not for them. This is for leadership.
Yeah, I hear you. Okay.
But there may be cybersecurity people in my presentation.
No, it's a very good
Because
point, and a lot of people forget
it-
that. I was picking on the cyber guys because they tend to do that. To them, it seems you can always buy more security, whether the risk and the returns. It's the same way when I was building race cars. I can get a thing to go 100 miles an hour fairly easily. The next 20 miles is going to cost me, and the next 10 after that's, a quadruple in investment. So it's a very, very good point.
Yeah, I like your idea too from quality management is quality is free, that
Yep.
Phil Crosby's quote,
Yep.
and I think basically what that says to me is that, if you get the system right at the beginning, you basically, you're going to save tons of money later.
Mm-hmm.
Anyways, that's my presentation. Thanks for the feedback, guys.
It's good. Have fun with it.
Okay, thank you very much for your attention. And I hope you enjoyed the presentation. And let me know if you want a copy of the slides and want to use them for your own purposes. Just put a comment in my LinkedIn page, and I'll send you the slides. And as I said, I'll be presenting this on December 2nd to the Canadian chapter, and it might be a little different. I might add some of the ideas that came up in the conversation today to make the presentation better. And if you have any suggestions between now and December 2nd on how I can make this presentation better, I'd love to hear it, because I want to make it the best it can be. And so yeah, I hope to see you on December 2nd, and thank you for your attention.